Welcome back, Algebros. In our last video, we talked about distribution, the process of going from a term next to a binomial, and then making it something that's just expanded. Well, the process of distribution goes even more than that. What if we had two binomials multiplied together? Keep in mind that a binomial is nothing more than two terms added together, or subtracted. Remember, they're basically the same thing. So if we could go from a factored form to an expanded form or a standard form using distribution, can I do the same thing if I have a binomial multiplied by a binomial? How can we go from there to have no more parentheses, just a bunch of terms added up? That's our goal. That's what we see next. The answer is pretty simple. We just do the distribution process, but now twice. Each term in the first is now going to visit each term in the second. Let's see that right here in this first example. X plus 1 into, keep in mind right there, if it's just multiplied like this, there's no operation, it's multiplying, and we sometimes read it as into. X plus 1 into X plus 2. Let's read that note very carefully. Each term in the first. So in this one right here, the two terms I have are X and 1. Each of these are terms. It's now going to visit each term in the second. And if you saw before, this process was called double distribution. So all it is doing our distribution that we know twice. The first time for the first term, which in this case is going to be X. So let's do that. X is now going to visit each term in the second binomial, indicated by the arrows right here. X times X is X squared, and then X times 2 is now plus 2X. That was one round of distribution, but wait, there's more. The second term that we deal with here is this 1. And that 1 is also going to visit each thing. So that was each term in the first, now visiting each term from the second. X visited both X and 2, and now 1 is visiting both X and 2. 1 times X is X, plus 1 times 2 is 2. We do have one last step right here, which is going to be to combine the like terms. Will there always be like terms in situations like this? In the ones I'm about to give you, 100% absolutely. Have a look at this very carefully. X squared doesn't have anything like it. 2 doesn't have anything like it. But 2x and x, those sure as heck can be combined. So x squared plus 2x plus x. Remember, it's as if we have a 1 right here, so it's going to be 3x plus 2. The result of double distribution often results in a 3-term expression. If 2-term expressions were binomials, in this case we call them trinomials. Straightforward, right? It's all in a name. I do give a little bit of a warning right here, and I'm going to draw myself an algebra fairy next to it because, gosh, this is important. Watch out for minus signs. Those are always the thing that trip you up. They always follow the term that is directly to their right. And we'll see an example of that right here. Starting off with this example, x minus 3 into x plus 2. Keep in mind the comment that I set up here. Each term in the first is going to visit each term in the second. Always start off with the very first one you see, this x. And that's going to visit each thing in the second. It's very similar to before. X times x is x squared, don't forget that. Plus x times 2, 2x. Now here's where that little warning could come into play. The next term isn't just 3, it's negative 3. We gotta watch those pesky negatives, so I'm not just multiplying 3 by the x and 2, I'm multiplying negative 3 by the x and 2. So negative 3 times x is going to be negative 3x. I'm putting an extra circle around this negative because, wow, that's important. It changes the entire answer. And then negative 3 times positive 2 will be negative 6. Combine the like terms together here. We'll have the 2x and the negative 3x, and I'll have x squared minus x minus 6. Short, simple, easy, and fun. Speaking of fun, I might teach you a song about that later. Stay tuned. Let's see an example where negatives exist on both of the binomials. Let's see that right here. We start off by having the terms of the first visit the ones in the second. I'll start with the first one. X times x is x squared. But oh, we've got a bit of an issue right here. This isn't just 6, this is negative 6. And the minus follows whatever is to its right. In this case, that's 6. So anytime 6 is multiplied, you have to take into account this negative. X times negative 6 is negative 6x. That's first. Let's go to my second. Negative 5, I have to account for this negative right here. Don't forget them. This is probably the thing that's going to bleed you a lot of points. Alright, negative 5 times x is negative 5x. And oh my gosh, negatives collide. Negative 5 and negative 6. Oh my gosh. Oh wait, it's just 30. No worries. Negative and negative cancel out. It's like you're never knots. Take that equals. And you're going to have x squared, negative 6, minus 5, negative 11x, plus 30. One last one before I let you guys loose on your own. In this case, we have a mixture of weird variable terms. Don't let it jumble you up, though. This is still 2x as the first term in the first. And it's going to visit everything in the second and pass out its party favors. And then after that, this 1 is going to do the same thing for the second. So let's figure out what that does. 2x times 3x. Okay, let's be careful there. It's 2x times 3x. Numbers get multiplied together, so 2 times 3 is going to be 6. And the variables get multiplied together, so x and x gives me x squared. After that, we're going to have 2x times negative 4. That's a little bit easier. Negative 4 times 2 is going to be negative 8. And then just the x leaves it with just x. Finally, 1. 1 times 3x. Oh, that's just 3x. And then 1 times negative 4. Just negative 4. We like 1s. 1s are helpful. 1s are easy. And now we combine negative 8x and 3x. So it's going to be 6x squared minus 5x minus 4. Double distribution's fun. And like I said, I'm going to teach you guys a little bit of a song about it as well, in case you've learned about it in a different way. But let's see this real quick. A couple of tries. I'm going to trust you guys to handle that on your own. You've got this, Algebros, and I'll see you in the next one.